Okay, so connecting with the previous lecture, today I'm just going to show you that how you will calculate a specific area under a specific normal curve without using the integration. Just like we calculate using specific area in a specific interval while using the integration. But we will use in today's lecture a standard normal table, which is also called Z table, in order to calculate a specific area under a specific normal curve. So once again, I am just going to start the definition of a standard normal curve. A normal distribution, so we transform a normal distribution to standard normal distribution, which the mean of their standard normal distribution is 0 and standard deviation is 1. So this whole area will be equal to 100% and it will be mean. So the right hand side of the mean will be plus values and on the left side of the mean will be negative. So this is a symmetric distribution. We basically transform. This is the probability distribution function of normal distribution. So normal distribution will be transformed to standard normal distribution. When you transform the standard normal distribution, this x will be changed to z and z will be equal to x. So z will be equal to x minus mu divided by standard deviation. Okay, so the mean of the standard normal distribution is equal to 0 and the standard deviation will be equal to 1. So proceeding to the next section, the standard normal distribution. If each data value of a normal distributed random variable x is transformed into a z-score, the result will be the standard normal distribution. So basically this is the normal distribution. The mean of a normal distribution is lying at this place where mean, median and mode are equal, lying at the same place. That is why it is called symmetric distribution, which is also called a bell distribution. So this is the standard deviation from the mean, which is also called spread, which will tell us the deviation from mean. So when we transform this, we will write this z is equal to x minus mu divided by standard deviation. So this will be equal to the mean of this will be equal to 0 and the standard deviation will be equal to 1. So we will use standard normal table in order to calculate. So this is basically, I just want to show you the value, how we will calculate the z value from the z table. So the cumulative area is close to 0 for z score close to z is equal to minus 3.49. So I'm just going to show you that how we will calculate z is equal to, which is equal to 0. It means this area will be approaching to 0 when z is equal to minus 3.49. So at this place it will be minus 3.49. So that is why we just write at this place that z is equal to minus 3.49. So the cumulative area is close to 0 for z score close to z is equal to minus 3.49. The cumulative area is increased at the z score increase. So this z score will be going to up when the cumulative area is also going up. The cumulative area is z is equal to 0. So what will be the value of z is equal to 0? It's mean from minus infinity to z you cover 50% area. So the table will show us this specific value. So z is equal to 0. The value, the area which will be covered will be 0.50. So you can see when z is equal to 0, this will be the half area of this whole distribution, this curve, mean half % area will be covered. So this is 0.50. So when you going toward the right hand side, it's mean the positive values. For example, z is equal to 0.1, z is equal to 7. So this area will also be increased. And at 3.4, when value of z is equal to 3.4, it will be near to this point and it will be near to 100%. Okay, so these are asymptote, it will never ever touch this z line. So I have already calculated when z is equal to 0, the area will be 0.50. The cumulative area for z is this. The cumulative area is close to 1 for z score close to z is equal to 3.49. So the 100% area will be approaching to 3.49. I have already shown you while using the z table. So in z table, when the z value is approached to 3.49, this will be the whole 100% area. Now in order to calculate, find the area by the following direction for each case shown. To find the area to the left of z, it's mean to the left of z, this area. Find the area to the corresponding z in the standard normal table. Use the table. So now z is equal to 1.23. So how much area is this shape area, how much is it at z is equal to 1.23. So while using the z table, you can easily calculate this. Z is equal to 1.23. So you can see z is equal to, z value is z is equal to 1.23. So 1.2 and this is 3. This is 2 decimal place. So 1.23, it will be equal to 0.890. So you please note this. At this way you can easily calculate the area under a specific curve. So if we start to calculate, if we start going to calculate the area, we need to integrate the function. So how we will integrate the function? Minus infinity to 1.238, and then we will integrate the function of normal distribution, which will be very complex. So it will be very difficult to calculate while using the normal distribution. So that is why statistician transform normal distribution to standard normal distribution. So we can easily calculate the area from z minus infinity from a specific point to 1.23. So this area is 0.890. So you can see that the area of the left of z, so this whole area 1.23 is 0.8907. So with the help of standard normal table, we can easily calculate this area. Now I am just going to show you some more example, that to find the area to the right, now we want to calculate this area. So how we will calculate this area? So we have already calculated this area. We know that the area to the left of z is 1.23. So I already show you from the table. Use the table to find the area of the z score. So how we will calculate? Because the total area is equal to 1, the standard deviation of the z table is 1. So now we will subtract, the total area is 1 minus this area. So you will calculate this area. So from the table we calculate that for z is equal to 1.23, we just check the first column, which is 1.2, and the third, the 2 decimal place, and the 2 decimal place there was 3. So 1.23, the value was 0.8907. So when we subtract 1 minus 0.8907, we will get 0.1093. Okay, there is another example. We want to calculate to find the area between two z score. Find the area corresponding to each z score in the standard normal table. Then subtract the small area from the larger table. So how we will calculate this? So one of the way to perform this, to calculate this, we will calculate, if you want to calculate this blue area, so minus 0.75 to 1.23 and the function of f of x, t of x. So this is the normal distribution function. So if we start integrating this, it will be very complex, it will be very difficult, but if you people know the concept of standard normal distribution, in standard normal distribution, z is equal to x minus mu, this, and we will use these values in order to calculate the value of z of 1.23, and we will calculate minus 0.75 from the table. So when we subtract this area from this whole area, then we can easily calculate this blue shaded area. So now I am going to show you that how we will calculate z is equal to 1.23. How we will calculate this whole area? So in order to calculate this whole area, this whole area, we need to use z table. So z table. So we are looking for z is equal to 1.23. So this is z 1.2 and this is 3. So the z for 1.23 value is 0.8907. So you note this 0.8907. So you can see that z is equal to 1.23. This whole area is for z is equal to 1.23, 0.8907. Now we need to calculate this area, only this area. So how we will calculate this whole area? This area, this yellow shaded area, this whole area. So in order to calculate this area, for z is equal to minus 0.75, minus z is equal to minus 0.7. So z is equal to minus 0.75. So we will be going to minus 0.75. Minus 0.7 is this one. You can see minus 0.75, and this is 5. So you need to remember this column is 5. minus 0.75, minus 0.75. This 0.226 is the value of minus 0.775. You can see minus 0.75, which is 0.2266. So for z is equal to minus 0.75 is 0.226. So now in order to calculate this blue area, what we will do? We will subtract from this whole area for z is equal to 1.23, which is 0.8907. We will subtract from this whole area, this area, which is for z is equal to minus 0.75, which is 0.226. So you can see 0.8907 minus 0.2266. So this is equal to 0.6641. So use the table to find the area of the z-score. Now you people understand how we will calculate this value. Otherwise you will integrate this in order to calculate this area. And the lower bound will be minus 0.75 and the upper bound will be 1.23. So if you understand the meaning of standard normal distribution, if you understand how to use standard normal distribution, you will be able to easily calculate area of a specific interval. Now let's suppose there is another value. Let's suppose this is 1.53. Now we want to calculate this area. So how we will calculate this area, this shaded area? So first of all, you need to calculate z is equal to 1.53. What is the value in the table? Table value for z is equal to 1.53. So for z is equal to 1.53, we will use this table 1.53. You can see this is 1.5 and this is 3. This is 3 because at 2 decimal place this is 3. So 1.53, which is 0.9370. 0.937. So z is equal to 1.53. The tabular value is 0.9753. So the tabular value for z is equal to 1.53 is 0.9370. So it's mean that this whole area from minus infinity to 1.53 is 0.937. But we are only interested in this area, this shaded area, which start from 1.23 and 1.53. So now you can understand easily that 1.23 when z is equal to 1.23, the tabulated value for 1.23 is 0.8907. 0.8907. So now how we will calculate this area, this whole area, which is very simple. We can easily calculate. We can subtract from 0.9370 minus this area, this whole area minus up to this area, 0.8907. 0.8907. So when you subtract the tabulated value of 1.53, which is 0.9370, minus the tabulated value this area, which is 1.23, and the tabulated value is 0.8907, so you will get this. It's mean 4% of the whole area lies between 1.23 and 1.53. So in this way you will calculate the specific normal distribution area under a specific normal curve while using the tabulated value, while using the standard normal table. Otherwise you can use integration. So integration you will spend a lot of time. So this is the easiest way in order to calculate this.